Mm, yes, welcome to one another embedded system class. Uh, Afternoon session, theory. Uh, so we will make you to deliver the content in a very interesting way. Okay. Meantime, we need your cooperation also. Don't sleep by sitting in the other end. Get down from the bed and sit in the proper place and ensure we hope that you people are maintaining some class note regarding this subject. Please follow it. Okay. Yes. As usual, before starting the session, uh, what is the main content we have discussed in the last class? Apart from the design metric, we have discussed one new content. Can anyone tell me what it is? Last
Architecture of
class.
enterprise system. Okay.
Simplified architecture. Okay, so see, you may ask, sir, you are telling it is simplified. Then what may be the real architecture? Definitely, it has many more blocks. Whatever we have seen is a very limited one. Okay. Without making much delay, let me present my screen. Thereby, we will start the today's discussion. Before that, can anyone type or unmute and interact? What are all the blocks we have seen in the simplified architecture? Yes, even you can type in the chat box because I am leaving your chat box also. Yes, what are all the major blocks we have discussed in the simplified architecture of an embedded system? Yes, I think everyone is waiting for somebody to respond. Don't wait for others. Yesterday, actually, one new person entered. Sai Prince answered many questions. See, from this, it is clear that you people are expecting to call your individual names. Actually, the strength is little more in online classes. It's not possible to call everyone individually all the time. Okay, so try to contribute by your own. Whenever we find some discussion time at the time, we will try to call everyone's name. Okay. Google Nath, can you tell me any one or two blocks what have I discussed in the last class? Google Nath, Google Nath, are you there? Or let me call one more person. Somarisi, are you there? Okay, Puvaras, are you there? No one is there. Okay, Vikram, 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 Santosh. Okay, Priyanka, Priyanka, auxiliary coding system. Okay, then Vikram, unmute and tell. I have asked some question. It's not a question, it's like a simple discussion only. See, okay, human interface. Okay, thank you, Priyanka. Any other block what we have discussed in the last class? Appa, Sivapalan listed everything. DAC, ADC, software, human interface, uh, in between Jayavardhani typed something, actuator sensors. Okay, very good. So these are all the major blocks in our simplified architecture. Okay. So today we are supposed to start components of an embedded system. Okay. Before getting into the topic, the review already it happened. Okay. So these are all the block you people we have discussed. One thing I need to point out here, somebody asked whether it is a closed loop system. I forgot who asked the question. May I know who asked the question? May I know who asked the question whether it is a closed loop system or open loop? Somebody asked. At the end, Srihari also justified something. So, see here, this is the external environment in which, say example, we are going to measure the temperature and we are feeding the input via sensor, then unlock to digital conversion and slowly it enters into CPU CPU doesn't work in a single unit. It will take a help of these blocks also. So whatever the coding you have written, any other pre-default values in the memory, like that it will check with the remaining things also, and accordingly it will produce some output. If your system is a digital output, no need of this block. But if you record an analog output, obviously you need to introduce this block also. From there, it will produce the output. If there is any deviation, again, sensors. So again, this system is one of the closed loop system. Why not to think in that way? Initial stage, you may get confused with your open loop, closed loop, and you don't take the input of the real embedded function. Due to the purpose only, we limited you to not to think. At present, you can correlate that also. Okay, then one more wonderful question asked by the Srihari. Sir, you said how these blocks are going to work. We are happy. But how this electromechanical safety system going to work? Consider the situation in which your CPU is unable to process, but we are sensing temperature. Accordingly, I need to do some actuation. If this particular blocks are getting some fault, how I can bypass my system? That is the one wonderful practical scenario. If that is the case, we are encouraged to receive the input from the sensor. What is the quantity sensed by the sensor? It gives the input to the electromechanical system, safety system. Then electromechanical safety system itself will give some command to the actuator. Thereby, we are going to bypass our flow. Is it clear to everyone? Is it clear to everyone how your electromechanical safety system is going? See, now I am in the full screen mode. Whatever you people type in the chat box, sorry, I can't view it. The only way you need to unmute and talk. Okay. So that's all regarding the simplified architecture. With this idea, we will get into the components of an embedded system. The component of an embedded system and your simplified architectures are almost similar, but here we are going to discuss the things in a little depth way. Okay, before that, can anyone unmute and read or identify what are the hardware images thrown in front of you? Please, anyone, please? Anyone, please? Make attempt, no issue. Anyone? We have plenty of components. You answer any one or two. That's sufficient. Yes? What may be these images in front of you? Unmute and tell again and again. I am in a full screen mode. Yes? Any two component you point out, remaining I will tell you. Yes, I will do one thing. Let me point out few things and ask you. What is these two things? Okay, what about this fellow? What about this fellow?
I see.
Please don't tell simply it is IC, Rishwan. Here it's something written over there.
Intel
Core i7 processor.
Core i7 processor. Okay. Any other component? What is the second fellow? What is the second fellow name? Any idea? Okay, leave it. What about this? What about this? What about this?
ARM processor.
ARM Cortex processor or controller. Okay, then see what is the thing present over here? One small thing.
Battery.
It is not a battery, it is a cell. Okay, lithium cell. Then what about what something written over here? What is this? What is this?
Watchdog.
Read it. Watchdog. Watchdog. Okay, so that is sufficient. These are all some components what we are going to use in our embedded system. It is very much similar to our block, what we have discussed earlier. Here we are going to, say not a block, architecture. Here we are going to discuss something in detail. Okay, yes. The very first one is your CPU. So CPU already you know well. Here we are not going to detailed discussion. Here we are going to point something little different from your normal things. Okay. Now most of the time your CPU may be microprocessor or microcontrollers. Okay. So this chip, we are using this chip in our embedded system application. If you are using the processor, you need to use external memory chips. Why? Why? The processor won't support any memory, and any other hardware supports externally you want. You need to add it from external circuits. Okay, if it is a processor. Controller means in a limited way, you have other blocks also. Okay, that is the one thing you need to note down from this line. Then nowadays, even if I want to tell one wonderful CPU to you people means, we can quote the wonderful CPU you know in the embedded system world is the Raspberry Pi. Okay, there also you have one CPU. It is like a mini computer. There you have some higher level processor. Okay, whatever the microprocessor you have studied, all are lower versions. Okay, there are high performance processors available. Those processors will have pipeline, superscalar architecture, fast ALU, floating point processing unit. Don't worry about these individual keywords. Note it down. Note it down. Okay, we will discuss about these points very detailed in that section. Okay, this floating point you know in a C program, you will declare variables as a int or float. What is the float means? What is float means? What is float means? Is it a whole number or a fraction number? Is it a whole number or a fraction number?
Fraction numbers.
Fraction number. See, your processor will find difficult to deal with the fraction numbers. For that purpose, we are using some floating point processing unit in your chip itself. Today evening, we will share you one video. Do watch that one. In that, you will observe in your mobile phone how many chips are, how many different blocks are used to process your entire mobile phone operation. Okay, definitely we will share you today evening. Please do watch the same. Okay, then what is this pipeline? And a simple word, very simple. Lunch முடிச்சிட்டு வந்திருக்கோம் கரெக்டா? இப்போ வந்து பிளேட் எடுத்துட்டு வந்து அம்மா முன்னாடி வச்சாங்க. என்ன ப்ராசஸ் நம்ம பண்ணோம்? Can anyone tell me? பிளேட் எடுத்துட்டு வந்து அம்மா வச்சாங்க. நம்ம என்ன பண்ணோம்? சைடுல போனை வச்சுக்கிட்டோம். Because for all this, my side dish is my smartphone. Am I correct? Side dish smartphone வச்சாச்சு. அதுக்கப்புறம் என்ன பண்ணோம்? Can anyone tell me the process what we carried out?
Headphone remove பண்ணுவோம்.
What?
Headphone remove பண்ணுவோம்.
Headphone remove பண்ணுவோம். Then see, you are in front of the one favorable dish in front of you. What you will do?
நல்லா சாப்பிடுவோம்.
அதான் ஸ்டெப் பை ஸ்டெப்பா சொல்லுவாங்களா? அது ஸ்டெப் பை ஸ்டெப்பா சொல்லு. First we will take the food. Am I correct?
Salt போட்டு.
Wait பண்றா. First we will take the food. Then we will open our mouth and keep it inside. Then interesting topic சொன்னாலும் வாய் திறக்க மாட்டேன்றேன். Okay, first we will take the food. Then we will யாரோ ஒருத்தவங்க ஆன்சர் பண்ணலாமே. ஹலோ,
டேஸ்ட் பண்ணி
taste பண்ணுவோம். And we will mix with saliva and we will grind. Many process will happen inside your mouth. Am I correct? At the same time, there is one sensor present inside your mouth. It will give the command to the brain that I am going to give this one to your Stomach. Who's that fellow giving the input to the brain? நீ இதை மென்னு சாப்பிட்றன்றதை அவர் சொல்லிடுவார். Who's that fellow? Quick. Costliest sensor. It's not available in Amazon. கொஞ்சம் quick-ஆ.
Taste.
Taste buds in your tongue. Very good. Then after some time it will reach your stomach and it will get digested. Okay, the digestion process will take place. Very simple. Whenever we are giving some instructions to the controller or the processor, it will fetch the instruction. So whatever we are writing the instruction, it may be opcode, it may be some high level language that can't understand by your processor or controller. Your processor and controller can understand only ones and zeros. Can anyone tell me, after fetching the instruction, what is the next step we need to do? We need to decode. We need to decode. Very good. We need to decode. Usually we are decoding inside our mouth. Okay, then what we have to do?
Execution.
That's all. See, it's very simple concept, but it is a very powerful concept. Okay, so in a lower version microprocessor and all, whenever I am doing the fetch action, my microprocessor can't think decode. After completing the fetch only, I can do for decode. After decoding only, I can get into execute. But wherever you find this pipeline architecture, we can do some simultaneous action that we will discuss in the later part. At this point of time, you need to remember the pipeline will give some flexibility to do these actions in a simultaneous fashion. Note down this one. Please note down this. Remaining thing, superscalar architecture. What is the superscalar architecture? It has 2 or more sets of instruction executed in the parallel pipelines. Don't worry. Superscalar architecture pipeline things we will discuss in detail. At this point of time, note down this. There are some advancement in your microprocessor what we are choosing for our embedded system application. That's all. So example ARM and Pentium processors. Then we will get into the controller. So controller, what is the difference between the microprocessor and controller? What is the difference between the microprocessor and microcontroller? Microprocessor is a simple processing unit, but controller consists of beyond processing unit. What are the things you will have? Tell me in 1 or 2 blocks inside your controller.
IO memory.
IO memory. Then anything else? Last class we have discussed a few blocks.
Serial UART.
Serial UART, very good. Anything else? Last class we have discussed a few blocks. Try to keep all the blocks into the CPU. After sensing, what we used to do? We used to do some conversions, am I correct? We used to do conversion in both the input and output side. What are those conversions? Shall I show the
ADC,
diagram?
DSC.
ADC, DAC. So like that. What is the idea behind this means? In a single silicon chip, if you accommodate many things, communication between these things will happen in a very faster way, because all are manufactured using the same silicon. Thereby the communication speed is more. Thereby the efficiency of system is more. Thereby the power consumption is less. Many advantages. That is the idea behind every version update in your mobile phone. For mobile phone name, there is a software update and a hardware update. The hardware update makes the things to work in a very fantastic way. Okay, they are feeding many investments, $1 million in the hardware investment. Okay, try to browse these kind of industries, where it is, what they are doing, how to get into that, what are the knowledge I should have. to get into the industry. Please think it in that way and try to gain those knowledge and appear the interview there. Definitely will get a chance to work there. Okay, yes. Fortunately and unfortunately, unfortunately in India, we don't have much chip manufacturing industries, but nowadays we started some mobile phone manufacturing industries. Okay, soon I think chip manufacturing will also come in a successful way. In the last pandemic, from IIT Madras, they created one chip. That video, if possible, we will share it to you. Okay, and the IIT itself, they fabricated one microprocessor. The name, sorry, I have forgot that. I will tell to you later. Okay, see what are the things available in a single chip. You have interrupt controller, port, timer, pulse width modulation, CAN. It is one protocol used in the automobile. Take down only this point. CAN is also like one protocol, as like a USB protocol. Okay, well, note down. So these many things are available in a single chip. Okay, so how we are going to categorize our microcontrollers in the embedded system field means based on the number of bits. I think you already know small scale, medium scale, large scale. Already we have discussed. Am I correct? We have discussed. Am I correct? So even there are some curriculum. We start embedded system with a PIC controller. So the famous PIC controller used in our college days is PIC 16F877A அப்படின்னு ஒரு ஐசி இருக்கும். இந்த ஐசி தான் எல்லா ப்ராஜெக்ட்லயும் control. Nowadays, if you observe, Arduino is present in most of the projects. Am I correct? In the same way, while we are studying our engineering curriculum, 80% of the project will fall in this PIC microcontroller. 16F877A, very, very popular controller. It is also affordable. Little easy to code, so the students will catch only the particular controller. Okay, but we are not going to touch these PIC and all. We are going to touch only the ARM family. Okay, yes. Even in our KC, we have a Texas ICs also. If you are interested, whenever you are having offline mode, try to get those ICs and do some projects. Okay, so these are all some types available based on the number of bits in the particular controller. Okay, yes. Then what else? Okay, that's all about your microcontroller. Here there are few interesting things shown in these slides. It's called coprocessor. So coprocessor for floating point operation. As I said earlier, in the microprocessor, what we will do, we will add some blocks to improve your computational power. Okay, a floating point, we will use some chip. Okay, then for pixel process, pixel enga process pannum, can anyone tell me? Pixel process, you have some chip. Where we do this pixel processing? Any idea? Unmute and tell please. Pixel processor. Where we will use? Think about your mobile phone and tell.
Image.
Image. Where you will do? After your selfie, your mobile phone will do this process. Am I correct, sir? Taking selfie. During taking selfie itself, it is giving one box like this. And it is, you can zoom it. You can do plenty of things. Am I correct, sir? Am I correct, sir? Am I correct, sir? So those kind of image related process will take up by a single processor. Okay? Then you have, we will list a few more. Encryption engine. Can anyone tell me what it is? Encryption, decryption. Can anyone tell me? How many of them have in State Bank internet banking account? SBI internet banking account. Username. How many of them have it?
Yono SBI.
Yono SBI. Okay. See, here you will type username. Star. Username may be the full one. Your password, most of the time star. Since I am using this account and I am observed this one, I am giving as a single code to you. Okay. Why this star? Why this star? Why not the same password? You can type it here. Because nowadays, most of the time, we people are under surveillance, camera killer. If you type all the things, your camera will take the information. So, star. If you are observing your state bank money transaction at the time, if you type the password may be a 7 character or 8 character, with no time, it will create a dummy character with a lengthy character. Can anyone observe that? Who are having state bank account, do money transaction, you will observe. Okay, immediate it will take some more character in that. That is called encryption. It will add some information additional into that, thereby no one can hack your password. Then, while it do process inside, what is the opposite process of the encryption? What is the opposite process of the encryption? Decryption. Am I correct? Encrypt பண்ணும் decrypt பண்ணும். So example, இங்க ஒரு key இருக்கும், இந்த key போட்டு lock பண்ணிட்டா இங்க ஒரு key போட்டு open பண்ணி யூஸ் பண்ணிக்கலாம். So these kind of things are widely used in the defense sector. Whenever they are passing some message from one point to another point, they are doing this encryption decryption. Nowadays in IoT, this is a very powerful one we need to do, because many of the medical parameters we are sharing through the internet. To have a privacy, I should do some encryption. Okay, so blockchain, many techniques where they were introduced. We will no need to get into that much. Then network processing. Our mobile phone can do some network IP type பண்ண போது, web page type பண்ண போது, how it works. Normal processor won't give those supports. For that, we are using some network processor inside. So this is the idea behind some Crow processor. A few more coder, decoder, coding the image, decoding the image, converting into JPEG, this format to this format, that and all taken care by this coder and decoder. Okay, then Java code. Java accelerator is available in your mobile chips. Please find it. What type of it is? I think Java is the 8-bit code. Am I correct, sir? Java is the 8-bit code, but your ARM is a 32-bit. So how to convert this to this? That and all taken care by your internal blocks. So that's all regarding your processor and control. It is a very lengthy topic. Try to have some own interest and browse something and read it by your own many things. Then power supply. See, if I want to work, I need to eat something. Then only I will get some energy to work. In the similar way, how our silicon chips works. Obviously, my silicon chip requires power supply in the form of AC to DC conversion or chemical energy to the electric energy. So most of the time, we are giving some chemical energy to electric energy. That is your battery cells. Okay, battery or cells. Okay, these are all various voltage levels. In olden days, we will deal with some higher values like 12 volt, 9 volt. Nowadays, please observe 5 to 3.3. Then still it came down to 2, still it came down to 1.5 volt. So the silicon chips are manufactured to operate in this very, very low value because of your silicon fabrication technique, VLSI, GLSI, many techniques are there to make the silicon fabrication, GLSI. So those techniques will give some idea to make some modifications in the fabrication, thereby we can operate in the very, very low voltages. If you think about these very, very low voltages, by doing little energy harvesting unit and doing some control, directly you can give it to your controller. Okay, so that is the idea behind that. Can anyone tell me what is this plus or minus? What is this plus or minus?
Tolerance.
Tolerance level. Say example, 5 volt plus or minus 2.5 means 5.25 is the maximum value, 4.75 is the minimum value. Below that, if you give, nowadays your controllers are too smart. Therefore, only your mobile phones are called as a smartphones. Okay, your controllers are too smart. It will go to sleep or it will shut down the system if it go to some less than some threshold value. But if it goes beyond, what will happen, sir? What will happen, sir?
Saturation.
Saturation, okay. What will happen to your real hardware? It will become swaga. Am I correct? Am I correct, sir? It will become swaga, but it won't become swaga. Can you tell me what may be the additional one here? Here sleep or shutdown. Here what may be the additional one? We may have it before your chip and power. You have some kind of protection circuits, surge protection, okay, high voltage protection, under voltage, over voltage, those and all taken care by specific hardware circuit. Thereby you no need to worry about this. Think lot in this area, whenever you think about the IoT and e-vehicle, many concepts you need to think about this power supply. So think much, do something, and get something. Okay. Why this many low voltages? Because of the CMOS technology. But the TTL, it is not possible. TTL ke evlo sir voltage veno? TTL ke transistor logic me evlo venu sir? You need 5 volt. So if you change the technology, you can bring down the voltage. Okay. So thereby power dissipation will be less. Thereby lifetime of your cell will get increased. That is the idea behind this power supply. Anything else you need, a low power system can be packed in a lower space because of low power consumption. Yes. I square R loss is the heat. Everyone knows. Am I correct? So upon the loss coming out of the bina, you can reduce the silicon size. Silicon size reduce panna, cost you can reduce. Size of the system will reduce. Many things will get reduced. Form factor will get increased. Okay. Then clock. What is the purpose of the clock, sir? What is the purpose of the clock in your microprocessor, microcontroller system? Quick. Microprocessor or microcontroller system. What is the purpose of the clock?
Synchronization.
Synchronization is the additional feature. So what is the? Okay, let me ask you in a different way. What is the purpose of your heartbeat? Heartbeat ஆகல, ஹார்ட் வந்து தூங்குது 10 நிமிஷத்துக்கு. நம்ம என்ன பண்ணுவோம்? We will be in mortuary. Am I correct, sir? Heart taking rest for 10 minutes mean we will be in mortuary. Am I correct, sir? What for that pumping required? What for the pumping in your heart? எதுக்கு சார் ஹார்ட் பம்ப் ஆகணும்? Why so?
It's okay, sir.
Blood circulation. The same way, your chip is all a semiconductor device. It is powered. It has to do some action. It needs some reference. Fetch the instruction. When I need to fetch? What is the length of the instruction? How I can find? For all the things, I require some reference. What is that reference? Tick, clock. Is it okay, sir? Tick, clock. What is this tick, clock? This time, do some process. This time, you do some task. Positive edge, negative edge, rising edge, falling edge. Many parameters are in the clock. Am I correct, sir? First 2 clock pulses do this task. Second 2 clock pulses do this task. Like that you can give some instruction to your processor or the controller. So the tick clock is very important. That is your reference. Based on the reference only you will work. Okay, sir? Then from where I will get the clock pulse? Whoever register for the design of IoT and watched the videos, you may aware of this term called what is oscillator. That professor explained in a very lengthier way. Even you studied these things in your microprocessor, microcontroller. What is mean by stable? Highly stable. So நம்ம ஒரு frequency set பண்ணோம்னா அது அந்த frequencyல அப்படியே இருக்கணும். புரியுதா? After some time it is collapsing like this. Your system won't perform in a record level. Okay. So அதுக்காக we are going to have a stable oscillators. So most of the time, your chip itself inbuilt, you have RC oscillator. Okay. RC oscillator என்ன சார்? Resistor capacitor combinations use பண்ணி அதுக்குள்ள ஒரு oscillator form பண்ணிருப்பாங்க. oscillators are 1, it will produce some waveform it will produce பண்ணும். Using this waveform, you can create square wave. Using the square waveform, you can do some function in your processor. Okay. And the oscillators will be stable. Many types of oscillators are available. What is the purpose of these oscillators are do some timer action and real-time clock functions. So this additional function. Okay. Timer action pannalam. That is your RTC, real-time clock. In a very, very first initial slide, we have asked you what it is, but no one interested to read it here. It is a real-time clock. In your laptop or computer, sometime your date in the computer may not be correct. It will ask you to change the CMOS battery. Am I correct? Am I correct? In your motherboard, you have one RTC. See, I am making my laptop to shut down. And I am turning on tomorrow. But tomorrow it is update is not updated. No, I am not connected with the internet. Then how it is continuously works? So we have one real-time clock inside your motherboard. If the cell fails, it will forget the date. That's all, very simple. This is your real-time clock. Okay. So in the functions we are using the clock, timer function. Timer, you know, okay. Then scheduler. Scheduler is very simple. We are scheduling some task in your mobile phone. 6 a.m. alarm, 9 a.m. Google Meet, then 4 a.m. PUBG. You schedule பண்ணி வைக்கிறியா calendarல reminder கொடுக்குதா? How it gives the help of the clock and your schedule. You can plan your task. Okay. Okay, sir. Okay. So likewise, we have many things under your then timer and counter. These functions you are doing with the help of the clock. Now we will see one fantastic component present in our embedded system. That is your. Can you read what the title it is? What title it is? Quick, sir. What title it is? What title it is?
Watchdog.
Watchdog timer. Okay, what is the purpose of dog in our home? Is a dog vechirukka our home la for watch something. Edha watch pannu? Edha watch pannu? Edha watch pannu? It will watch something. Edha watch pannu? It will watch you. Huh?
Some other dog.
Okay. Other than that, it will do. It will observe some third-party persons. Am I correct? If they come near to the door, it will start doing function. Am I correct? So நம்ம ஒரு படத்துல பார்த்திருப்போம், ஒருத்தர் வந்து திருட போவாரு. திருடுறதுக்கு முன்னாடி அவரோட ஃப்ரெண்டு கிட்ட வந்து ஒரு பிஸ்கட் பேக்கெட் கொடுத்துட்டு போவாரு. அவங்களுக்குள்ள ஒரு கால்குலேஷன் இருக்கும். ஒன்னொன்னா போடுவாரு, ப்ராப்பரா போயிட்டு இருக்கும். அப்புறம் அது இன்பிட்வீன்ல கொலாப்ஸ் ஆயிடும். வாட் இட் இஸ்? கேன் யூ ரிகலெக்ட் தட் scenario what I am spelling? Yes? Hello sir. பிஸ்கட் கொடுத்துட்டே இருப்பாரு, நாய் கத்தாது. பிஸ்கட் தீந்தோட நாய் என்ன பண்ணும்?
கத்தும் சார்.
கத்த ஆரம்பிச்சிடும். கரெக்டா? Same fantastic example here we are going to use. Before that, I want to draw your attention again to the same video clip. Please observe, this fellow is doing something to troubleshoot the function. என்ன troubleshoot, எப்படி troubleshoot பண்றான்னு சொல்லுங்க. ரோபோ இப்போ வந்து கொஞ்சம் மாறி ஃபங்க்ஷன் பண்ணுது. Closely observe what he did. Anyone knows? Please observe. Let me rewind. It is doing some malfunction. Okay. It is doing some malfunction. He is doing something. What is this? Any idea? Please observe. ஒரு பட்டனை பிரஸ் பண்ணி கையடிக்கிறார். What it is? Any idea? Who are familiar with the Arduino board? They know.
Humidity sensor, sir.
No, boss. கரெக்டா சொல்லுங்க.
ரீசெட் பண்றோம்.
Who said that answer?
வசந்த் சார்.
Vasant, thank you very much, Vasant. See, he is doing reset. Why? Any idea why I need to reset? Why I need to reset? Whenever I am finding my function is collapsed, see, I am having number of lines. My controller may be in this line and it gets stuck with here. I want to force my system to go back here and start execute from here. What you will do? You will do sleeping, correct? You will do
Reset, sir.
reset. You will do reset. Okay. Now this task is very simple. Now think, we launched one rocket. The rocket is far away distance from us. If you want to go there, you need to spend huge money. Tell me how you will reset this hardware by sitting here. Is it possible? How you will reset this processor far away or controller far away distance from you? How you will do reset? Quick. How you will do reset?
By signal, sir.
By sending some signal. Okay. Now my duty is over. Now I am sleeping. Who will reset? Don't tell இன்னொரு ஷிஃப்ட்டுக்கு இன்னொருத்தர் வந்துட்டாருன்னு சொல்லாது. ஓகேவா? ஒரே ஒரு பர்சன் தான் அதை பார்த்துக்கிறார். அவர் இப்ப தூங்கிட்டார், ரெஸ்ட் எடுக்கிறார். Who will do reset during midnight or some other time not controlled by the human? Who will reset?
Sir, there will be two kind of reset, sir. Software reset and hardware reset, sir.
Okay, when the hardware reset will happen?
Sir, if இப்போ நம்ம பண்ணா ஹார்ட்வேர் ரீசெட் சார். சாஃப்ட்வேர் ரீசெட்னா அது தானா ரீசெட் ஆகும். பவர் ஆன் ரீசெட்.
பவர் ஆன் ரீசெட், பவர் ஆஃப் பண்ணி ஆன் பண்ணணும். அதுக்கும் சம் பர்சன் வேணும். ஓகேவா? தென் ஹார்ட்வேர் ரீடெஸ்ட் வந்து வாட் எவர் யூ சீனியர் டிட் வாஸ் ஹார்ட்வேர் ரீசெட். Your software itself struck somewhere. Then how your software will reset? அதான்டா கண்ணே, என்னோட ப்ரோக்ராமே ஸ்ட்ரக் ஆகி இப்ப நிக்குது.
சார் இன்டரப்ட் சார்.
ISR தான். இங்க பாரு, say example, this is my main code 1 2 3. Then let me change the color. Call function. Then I have some subroutine. Then I am having some main coding. So in the main coding color main coding. Please observe Srikanji. This is my subroutine. This is my main coding. Somewhere I am going to call my subroutine. I got stuck here. Is it possible to skip these two lines and get into this line to execute my subroutine? Srihari?
Sir, no, sir.
Not at all possible. Okay, am I correct? So these kind of things happened already. Many defense relevant or some rocket launch. Actually, really sorry to say this, I forgot the story, but it is available in Wikipedia. I will share it to you. So, due to the simple function failure, we are unable to reset our system. For the purpose, the scientists invented one specific hardware that is called watchdog timer. It is a very, very simple concept of our same biscuit and dog concept. Do observe this diagram. And give 1 minute attention. I will make you to very, very clear. Before that, please tell me, what are all the major blocks here? Please assist me. What are all the blocks available, major blocks available here? Block 1 is processor. What is the block 2? What is the block 2? Konja solunga sir.
Watchdog.
Hello, watchdog timer. Okay, yes. These two blocks are supplied with clock. I'm going step by step. Don't get sleep. Please give some attention. See, remaining all are known to you. Okay, simply if I give a material also, you will read and write. Only these kind of new concept we need to teach. Okay, please allow us to teach. Okay, both the blocks are connected with the clock. Up to now, it is clear. Then, please observe two commands. One is from watchdog timer to processor. Another one command from the processor. Very clear. Am I clear to you, sir? Watchdog timer la irundhu vara signal reset signal. Processor la irundhu vara signal restart. Is it clear up to this? Is it clear up to this? கொஞ்சம் யாராவது சொல்லலாம்.
Yes.
Two blocks are tied with the same clock pulse. Then only two signals, reset and restart. Now please observe very clearly what kind of setup we will have. Very first, we will give some initial count value here. Say example, consider 10. Consider 10. Then your watchdog timer will do down count. Down count means what is the 10? After 10, what it will come? 9. After 9, 8. After 8, hello sir. After 8, நானே சொல்றேன் 7. After 7, Sai Prince 6 and so on. எது வரைக்கும் சார் போகுது? up to 0. அதுக்கப்புறம் என்ன ஆகும்? 10 10 இதுல இருந்து இந்த ஃபங்க்ஷன் நடந்துட்டே இருக்கும். Am I correct?
Yes, sir.
Yes, please observe. கண்ணா இப்ப யாரு எஸ் சார் சொன்னியோ கொஞ்சம் கன்வியூ பண்றா. நீ தான் கொஞ்சம் முடிச்சிட்டு இருக்கற, கொஞ்சம் கன்வியூ பண்ணு. சரியா? Consider I fed the value as a 10 and it is making some down count. At the time, the processor give restart signal. Say example, my processor gives restart signal during the 8th count. What happens to my count now? இப்போ என்ன ஆகும்? 8ன்னு வரும்போது என்னோட ப்ராசஸர் என்ன பண்ணிருச்சு? ரீஸ்டார்ட்ன்ற கமாண்ட் கொடுத்துருச்சு. அப்ப இந்த கவுண்ட் என்ன ஆகும்? Whether it go to 7 or it goes to 10.
10
Goes to 10.
That's all. நல்லா லிசன் பண்ணிக்கோ. We are giving some value, storing some value, then it making some down count, and my microprocessor will come and it will reset. It will come and reset. It need not to be exactly 8, somewhere, but before 0, it has to reset. Or else, what it means? Reset ஆகலன்னா என்ன meaning? My processor is hanging somewhere, or else my processor not completed the particular task in the given time. Immediately, with no time, my watchdog timer will go and it will do restart. Thereby, you can avoid some holding or hanging process happened in the processor. Is it clear to everyone? Shall I repeat once again?
Yes, sir.
Yes. Nalla listen pannikko. Simple concept but important concept. 2 block tied with the same clock, feeding some initial value, and it gets down count. Before reaching 0, if my microprocessor is restart, and the word marandradha. Example, the reset to restart maathi eludhirukken. If my microprocessor restart the count, it go back to 10, then it again will do down count. Then again microprocessor restarts, it will happen in a very fantastic way. But if my microprocessor failed to serve this signal and watchdog timer reaches 0, immediately watchdog timer will produce some reset signal to the processor. Thereby my processor will get reset. Then it will start run from by some initial locations. Is it clear? போதும், இதுக்கு மேல சொன்னா எனக்கு போர் அடிச்சிடும். ஓகேவா சார்? Yes. So this is the thing what I have discussed. Okay. Please read it whenever you find free time. It's a very, very important concept. There are some coding techniques available. How I need to do the watchdog predefined. First value set பண்றோம்ல, அது எப்படி செட் பண்றது? For that, I should know what is the time taken for the particular coding. இந்த கோடுக்கு என்ன டைம் ஆகுது எனக்கு தெரிஞ்சிருக்கணும். இதை காட்டிலும் ஜஸ்ட் கொஞ்சம் அதிகமா வச்சு நான் செட் பண்ணிடுவேன். அப்ப என்ன ஆயிரும், இந்த டைம்குள்ள இது முடியலன்னா ஆட்டோமேட்டிக்கா it will reset. Thereby I can avoid some malfunction, I can avoid some delay, I can avoid many. Okay sir, that's all regarding your watchdog timer applications. The fault developed systems, then அப்புறம் என்ன சொல்றாங்க, see control. ரொம்ப சிம்பிளா ஒரு எக்ஸாம்பிள் கொடுத்துட்டாங்க பாருங்களேன். We are sensing the temperature and we need to actuate something. ஓகேவா? அந்த டைம்ல என் ப்ராசஸர் தூங்கிருச்சுன்னு வச்சுக்கோ, இங்க டெம்பரேச்சர் அதிகமாயிரும். சே எக்ஸாம்பிள், மார்னிங் கிளாஸஸ் you have studied some thermal plant, nuclear power plant, many power plants you people are studying. Am I correct? The very thing, important thing is the heat to mechanical energy to electric energy. The heat may come from water or steam, something else. So most of the time we are producing the heat from the heat, steam. Many magics we are doing. All the power plant, the primary role, they will measure the temperature. If a system is sensing the temperature but it fails to give the command some corrective actions, then your boiler will get burst. The huge money loss. Not only to the particular power plant depend பண்ணி நிறைய பேர் ஒர்க் பண்றாங்க, அவங்களோட ப்ரொடக்ஷனும் சேர்ந்து லாஸ் ஆகும். Am I correct? So இது மாதிரி ஒரு சினாரியோவை அவாய்ட் பண்றதுக்காக they introduced this watchdog timer. ஓகேவா சார்? தனித்தனியா பிரிச்சு அந்த வடிவேல் காமெடியெல்லாம் பேப்பர்ல எழுதிராத, அப்புறம் என்னத்துக்கு வெளியே போட்டுருவாங்க. சரியாடா? Then reset circuit. So reset circuit you know well, but reset வந்து எப்போ நடக்கும்னா whenever you start the program to run, that is you are power on reset, then boot. Okay, sorry restart ஆனோன program flow சொல்லியிருக்காங்க. ஓகேவா? ஃபர்ஸ்ட் வந்து சிஸ்டம் ப்ரோக்ராம் பிகினிங் ரன் ஆகுது, பூட் லோட் ஆகுது, அப்புறம் இனிஷியலைசேஷன் நடக்குது, அதுக்கப்புறம் மெயின் ஃபங்க்ஷனுக்கு போயிடுது. இஃப் யூ டேக் எனி ஒன் ஃப்ளோ ஆஃப் யுவர் கோடிங், ஃபர்ஸ்ட் எடுத்த ஒன் ஹெடர் ஃபைல், தென் டிக்ளரேஷன், தென் இன்டு மெயின். ஸோ இந்த ஃப்ளோல தானே வரும். அதான் இங்க சொல்லியிருக்காங்க. இதுக்கு முன்னாடி பூட் அப்படின்னு என்ன சார்? இஃப் யூ ஆர் ஹேவிங் சம் ஆப்ரேட்டிங் சிஸ்டம், பூட்டிங் இஸ் த ப்ராசஸ் டு செக் யுவர் இன்புட் அவுட்புட் பெரிஃபரல்ஸ், இன்ஸ்பெக்ஷன். அது முடிஞ்சதுக்கு அப்புறம் இனிஷியலைசேஷன், தென் இட் வில் டூ த டாஸ்க். ஓகேவா? இது நிறைய டைப்ல பண்றோம். நீ இதுவரைக்கும் நீ படிச்சதுல பாத்தீங்கன்னா ரீசெட் பண்ணா 00 ஒரு அட்ரஸ் போயிருச்சான்னு சொல்லுவேன். பட் இந்த எம்பெடட் சிஸ்டம் அண்ட் ஆல் பேஸ்ட் ஆன் த ரீசெட், watchdog timer reset, பவர் ஆஃப் பண்றதை பொறுத்து யூ ஹேவ் அ டிஃப்ரெண்ட் வெக்டார் அட்ரஸ். ஓகேவா? Two type of startup address in general we are using. One is power up பண்ணினா இதுல இருந்து first address location run ஆகும். If you do any other reset, it will start from the second location. Okay, that is a new thing to you people. Please note it down. Two startup, one is for power up, another one is for any other resets. Okay, so watchdog timer also do some reset. Okay, then what else? Reset circuit. Hardware circuits available, dedicated ICs are available to make the reset. Reset circuit பண்ணும்போது reset operation எப்படிலாம் பண்ணலாம் அப்படின்னா, சாஃப்ட்வேர்ல பண்ணலாம், watchdog timerல யூஸ் பண்ணலாம், clock frequency monitor பண்ணிட்டு whenever my clock frequency is low level, your system will get reset. Clock pulse சொன்னேன்ல, அது லோவா இருந்தாலும் you can do reset. Okay, then And then that's all regarding your reset. Resetக்கு கொஞ்சம் ஹார்ட்வேர் சர்க்யூட்லாம் பாரு எப்படி ஒர்க் ஆகுது. You'll be having some capacitors, some resistor circuits, RC time constant. The RC time constant will decide your the pulse duration. நிறைய ஸ்டோரி இருக்கு, மைக்ரோப்ராசஸர் இருக்குது, ப்ளீஸ் கோ த்ரூ இட். அண்ட் இன்டரப்ட் ஹேண்ட்லர். ஸோ நம்ம பார்த்தோம்னா மைக்ரோப்ராசஸர் மைக்ரோ கண்ட்ரோலர் இன்டரப்ட் ஹேண்ட்லர் தனியாக ஒரு சிப் வச்சிருக்கோம். The chip will handle this interrupt handler and all. Okay, but here you have multiple interrupt handlers are available. Whenever interrupt comes, it goes to the particular service routine. Okay, wow. Service routine, we have many things. If you have more than one service routine, you need to set the priority. Okay, wow. So priority set பண்றதுக்கு we have many things. Then whenever you are serving one priority, one task, one subroutine, at that time if you don't want service any other service routine, you can mask the interrupt. Okay, இப்போ ஒரு பிளான்ட் வந்து தீ பிடிச்சி எரியுது, ஃபயர் எக்ஸ்டென்ஷன் ஆன் பண்ணி இன்டரப்ட் சர்வீஸ் ஆயிட்டு இருக்கு. அந்த டைம்ல போய் வேற ஏதாவது ஒரு ஒர்க் பண்ணுன்னு சொன்னா நீ பண்ணக்கூடாது. your controller should do only the fire extinction action. புரியுதா? So that அது மாதிரி some high priority interrupt வரும்போது we need to mask the other interrupts. Okay, அது இதை டிஸ்டர்ப் பண்ணி விட்டுருச்சுன்னா ரியலா நடக்க வேண்டிய ப்ராசஸ் நடக்காது. ஓகேவா? So like that many things are there. Software you people know well than us. C++, Java, what are the coding? Python, nowadays Python doing many things. What is the purpose of this coding? How to make your controller to work with the task and multi events and real time process. How to do? We are receiving several inputs in your mobile phone. At present itself, your mobile phone receives the temperature, humidity. If you walk, your mobile phone counts the step count. Likewise, it receives many inputs and outputs. How to process? Who is going to design? Software. Okay, sir? So these are all some important components in your embedded system. Now, உனக்கு தெரிஞ்ச ப்ரோக்ராம்ல என்ன சார்? OS operating program தெரியுமா? இங்க பாரு. Initialization configuration, operating system and runtime environment coding, application specific software, error handling software, debug and maintenance software. Sir, error handling software என்ன சார்? So whenever you are typing some C code, if you do compile, it throws some error. How your system know you did the error in the 66th line or 76th line? For the purpose, you have some error handling coding. And yesterday we have discussed about the debug and maintenance. How do I know in which I have many components in my system? The particular chip failure is in every கண்டுபிடிக்கிறது. For that also we are having some coding. What it means? You people can write coding in different sectors and you can catch your placement. These two put together in a single plan. Error handling is a different sector. Debug and maintenance is a different sector. Try to catch and learn these kind of softwares to excel in embedded system. Input devices, many input devices are there. Touchscreen, keypad, proximity sensor, then different port, then a barcode reader, your mouse, keyboard, many input devices are there. Output devices, fantastic output devices are nowadays available, these LCDs and all. Do browse and learn many things. Thank you very much. Any question and answers need to be addressed. Next week what we are going to study, I will tell you one thing. Do browse about the memories. We will discuss a lot on the memory in the next class. Already நீ படிச்சதா RAM na enna ROM na enna different types என்னன்னு பார்க்க போறோம். அதுக்கப்புறம் ஒரு கேட்ச் மெமரின்னு ஒன்று இருக்கு, முடிஞ்சா அது எங்க இருக்குன்னு கண்டுபிடிச்சிட்டு வா உங்க போன்ல. சரியா? ஓகே, தேங்க்யூ வெரி மச். எனி டவுட், எனி குவரிஸ், எனி அந்த கிளாஸ் ரூம்ல ஜாயின் ஆகாத ஃப்ரெண்ட்ஸ் எல்லாம் கொஞ்சம் ஜாயின் ஆகிக்க பார்க்கலாம். எங்களுக்கு கொஞ்சம் ஒர்க் லோட்